This conference is brought to you by CodeStack, React and React Native development experts.
Hello to everyone on the other side of the screen, and thanks to the staff for having me on this new conference edition. My name is Mateo Silguero, I'm 25 years old, and I'm from Buenos Aires, Argentina. I work as the leader of the front-end chapter at Anc, a fintech company based on Argentina too. I'm a mobile security enthusiast, and I'm co-organized a JavaScript meetup called Meetup.js. Before we start, I should read some disclaimers. The first one is don't get the title of this talk wrongly. It's just a play on words. The second is don't try this at home. If you perform some of the following tools or techniques on a third-party application, it could be considered illegal, depending on what you do and the country where you live. But I will not be responsible for your action. And the first one is this talk is focused on Android side. Then, why should I hack myself? Hacking yourself allows you to explore and detect vulnerabilities on your application before someone else does. When we deploy our app to the stores, it's available for the whole world. And maybe we are exposing API keys, sensitive info, or business logic in the code. Where to start? The first step is to get the artifact we want to hack. It will be an APK for Android or an IPA for iOS. We could generate the artifact from the source, for example, running the gradlu assembly command on the terminal or whatever command you have configured on your project. Or you can even use a web like APK combo to download it if the app was already deployed. This is APK combo. It's a website where you can search for any app on the stores and download its APK. In this case, ours is search for the Twitter app. This is not only for hacking. Some people prefer to use a website like this instead of the official store. The first part of this talk is about secrets. Now that we have our target APK, we can use APK tool for decompile the artifact into the source files. For example, running the D command with the path of the APK we want to decompile. We can see this output on a new folder. And usually on a React Native application, the JavaScript bundle is inside the assets folders like this. Java code is translated to Smalley code, and it is inside the Smalley folder. And native libraries are under the lib folder. Finally, app images and resources are in the res folder, like this. Now we can explore the Android manifest XML and the JavaScript bundle to see if we are leaking any API keys or another sensitive info. For example, in this Android manifest, we are leaking the API key, and someone else can retrieve this information and use it for their own purpose. You can see the value of API key is super strong password, and it is hard-coded into the Android manifest, and the another key is referred to other file. The value of my secret is in the strings.xml file. And there's another XML files that could contain another secrets. You can also read the Smalley code looking for constants like this. We have the debug constant and the version code, etc. We could also find hard-coded info on the JS bundle. If the app uses JS core instead of Hermes, we are gonna see a minified JS file like this. We can use JS Beautify or any other tool to see the bundle in a better way. Then we can inspect the file looking for secrets. In this case, we found a super secret API key variable with the value admin1234. But if Hermes is enabled, the JavaScript code is compiled to bytecode, I mean a binary file. So if we look for our bundle, it would look like something like this. You can see that this is very different from the previous one. All the JS code has disappeared, but an attacker can still retrieve information disassembling the bundle back to Hermes structure set. We can use HVC tool, which can help us to disassembling the bundle to Hermes structure. This is how the instruction file looks like. Now we can look for in this file looking for secrets, and also we can modify this file and assemble again to the bundle. Currently, HVC tool doesn't work on React Native 64, but I think it will do in the future. And there are a few tools that can automatically analyze the app, looking for secrets, URLs, and keys, like APK-enum and APK-leaks. This is an example of the output of APK-enum in the terminal. It finds some URLs, but it can also find API keys or secrets, whatever. But also exists MobSF, which is a more complete tool, and it works both with APKs and IPAs. After analysis, it throws a fault report. In the interface of MobSF, you loaded an APK, and this is the result. It's telling me a lot of the APK information, like the name, the size, how many activities it has, and etc. This is MobSF2. This is a list of the URLs it found on the code, and it can also find Firebase URLs, emails, strings, or hard-coded secrets. Then, how do I protect my secrets and code? For JS code, I highly recommend to use Hermes plus Obfuscator.io, which is a Metro plugin. So the strings will be really hard to read and obfuscate, and our secrets should be protected. Be careful with the rules you enable on Obfuscator.io, because it increases the bundle size. And on the native side, we could use Progal, which comes with the React Native and Android, and there are also some paid SDKs. Anyway, as far as you can, avoid managing secrets in your apps or send them via network. They are not completely safe on the client side. The second part of this talk is about user data. Sometimes we have to persist data on the app, like user info, interaction records, and app states. Async storage is the most common library to do this because it was part of the React Native core, but it has one problem. All that you save is persisted on an SQLite database file as plain text. An attacker could retrieve those files and read the saved data. We could simulate this scenario using ADB. ADB stands for Android Debug Bridge, and it comes as part of Android SDK tools, so you probably will have already installed it. ADB helps us to manage both emulator and physical devices, and upload and download files and apps from those devices. We will need a root device or an emulator without place services to get access to apps' private files. For example, we could run the devices command to list all emulator and devices connect it to our computer. Then we can run the root command to set a device as root mode, and then we could run the shell command to get access to that device shell. Into the shell, we could run the ls command, for example, to list the files inside that device. And now we can browse to our app scope, for example, cd data /data/ and the app name. In this example, we have an app called com.rila, and under the databases folder inside com.rila, we could find the RK storage file. This is the default name for async storage library. Then we could exit from ADB shell and run the pull command to download those files into your computer using this command. And now you could open the RK storage database file into any SQLite browser. For example, SQLite browser. Now we can see that we have the super secret key with don't tell anyone value into the database file. To prevent this, there are some alternatives like React Native Encrypted Storage, or my favorite, MMKB. MMKB is a C++ library developed by Tencent. Tencent is the company behind Widget and another apps. It is optimized for mobile applications, and there are some wrappers for React Native. For example, React Native MMKB storage and React Native MMKB. This library has some advantages, like it is even faster than async storage. It is 300 times faster on Android and 1,000 times faster on iOS. Also, we could store every type of data, not only strings. And it has an opt-in for data encryption, so we can protect what we are storing. MMKB saves the data into a file too, but if it's encrypted, it cannot be read without the encryption key. This is the path to the default file, MMKB's file, and this is how it looks without encryption, and this is how it looks with encryption. And the third part of the talk is about apps behavior. And we must talk about Frida. Frida is an amazing reverse engineering tool which allows us to hook the code execution from an app. We can define some scripts that could change the app's behavior without modifying the original code. For example, in this case, we could intercept the location module and always return the same coordinates. The use cases for this tool are almost unlimited. For example, in this script, we are hooking the location module and changing the implementation of the get latitude and get longitude methods, and always return the same latitude and the same longitude. Frida has also a module called Frida Trace that logs any function call on the native side. For example, we could run this command, Frida Trace. This is a regular expression of what we want to log, and this is the package name. This is an example of what are we logging. For example, multi-set and multi-get methods of the async storage module are logged to the terminal. To use Frida, we will need a root device or to patch the target artifact, and the best way to do it is using Objection. And this is a tutorial on how to do this. Try Frida and see what happens on your app. By doing this, you could identify some vectors and prevent someone else from bypassing any validation in your workflow inside the application. You could try to prevent someone else from using Frida in your app by blocking root devices and making an integrity check. JailMonkey is an option for React Native for detecting root devices. And integrity check helps us to know if the original artifact was modified. For example, if we patch the artifact. Also, obfuscators made the code harder to read and harder to use Frida. JailMonkey can detect Frida, but Frida could bypass JailMonkey. For example, using this script, we could hook the JailMonkey module and return false for every validation on the library. For example, if broken false, could detected false, and so on. This is a guide from I took this script. Okay, and now we have a short demo on how to use Frida. This is a React Native project. I will go to Android folder, run the build command like Radley assemble release. This will take a while. While this is combining, I wrote this as Frida script in Python. This is the JS code we want to run, which hook the JailMonkey implementation. And we can run it using the Python 3 JailMonkey.py. Okay, now we have our APK. I will move it to the root folder, like cp app build outputs APK release app release APK to the root folder. Here. Now we can use, this is the original APK. Now we can use objection to patch the APK and enable Frida on it. So objection patch APK from architecture x86. This is the same of this emulator, and S flag to the path. In this case, release APK. Sorry. Objection will download the Frida gadget and install it to the APK. This could take a while. Okay. Okay, now we have a new APK called apprelease.objection.apk. We can start the original APK to make a test, like adb s emulator 54. This is the ID of this emulator. And install release.apk. And now we have the Relab app installed here. It says true for root device because every emulators are taken by root device. And now we can do the inverse operation like uninstall on Relab, and now we can install the patched APK. Okay, we can open it, and this is white because it's waiting for a new Frida connection. Now we can run this script with Python, and now it says false and seems like it. Now we can do a login or whatever we want. This console log is from here. We are hooking the implementation and put all the variables into false. This is the original code. I will commit this to my GitHub account, so you can review it later. And that's the demo. Final thoughts from React Native docs. There's not a bulletproof way to handle security, but you can do your best effort to reduce the possibility of someone else hacks you. Sorry. Next steps, you can keep learning about ethical hacking, practicing on the app of the company you work for, and there are also some hacking labs which give us testing apps to try and learn new tools. For example, these two. And there are other topics to investigate, like network traffic proxy, public deep links and activities, etc. This is a complete list of useful links and resources where you can keep learning about the previous topics. And that's all. If you have any question, please contact me on Twitter. And that's all. Muchas gracias.